ride height gauges are used to reset the vertical position of the rear axle relative to the chassis after making setup changes. So for example, the gearing might be changed and that would affect the swing arm length, or a different link could be installed and that would change the angle of the swing arm. These gauges are especially useful for Ducatis and MVs that have eccentric rear axles. With an eccentric rear axle, when the gearing is changed or the swing arm length is changed, the vertical position of the rear axle is also affected, and that can raise and lower the rear of the motorcycle, and that would translate to a change in rake and trail at the front of the motorcycle. You can see in this image that the ride height gauge plugs into the frame, usually near the swing arm pivot and then above or further forward, and extends rearward horizontally above the axle, and then a measurement is taken down from the gauge to the axle. This is an example of the Ducati Super Sport gauge, where a tape measure is used to take that measurement. There is also the Ducati Superbike gauge. This has a built-in scale as well as a plug that inserts into the rear axle. Here's another example of a Ducati gauge on a MotoGP bike. You can see that it has the ruler built into it and bottoms out on a red plug in the rear axle. And here's an example of a BMW Alpha gauge. It plugs into the frame and it has a scale built into it as well. The ride height gauge is preferred to measuring off the rear subframe or bodywork because these could be bent in a crash. The ride height gauge can be stored safely in the garage and use a consistent reference. It also allows comparison with other people with the same gauge, whether it's the manufacturer who might have some recommendations on rear ride height or specialized tuners. And using a common gauge means that they can have a consistent reference for rear ride height. The calculated ride height measurement is displayed in the ride height reference row in the lower half of the screen, and the gauge specification is under chassis and then rear ride height references. For the BMW in column 1, you can see that it has a dimension gauge specified. There are also options for the map gauge specification as well as specifying a point on the subframe. For the dimension gauge, measuring the gauge and specifying it in MotoSPEC requires the use of a digital inclinometer to measure the angle of the gauge relative to the chassis. This is what a digital inclinometer looks like. Under the dimension gauge specifications, you can see all the measurements that were entered to specify the gauge. If we looked at the map gauge, it uses two pairs of swing arm length and ride height gauge measurements to determine where the ride height gauge is in space relative to the chassis. So choice of whether to use the mapped gauge or the dimension gauge specification can be determined by whether or not you have a digital inclinometer. Another consideration for both gauge types is that it is necessary to have a very accurate measurement of the swing arm length, especially for motorcycles with eccentric rear axles, because the swing arm length will determine the position of the eccentric rear axle adjuster and therefore also the vertical position of the rear axle. If you're using a tape measure to measure the swing arm length, it's important that it does not bend around foot pegs or exhausts, and the swing arm length measurement must also be accurately referenced to the center of the pivot and the rear axle, preferably with the use of a pointer or a plug. It is also important that the ride height gauge is tight and cannot shift relative to the chassis. You can see here in this image that there are slots that allow for adjustment of the pivot locator in the gauge. These bolts should be tight to ensure that the gauge is always located in the same position relative to the chassis and there's no slop or float. Looking at the dimension gauge specification, we can refer to the MotoSPEC help manual for guidance on how to fill in all the required specifications. At any time in MotoSPEC, you can press the F1 key on the keyboard and that will open the help manual to the most appropriate page. Here is the MotoSPEC manual. Open to the new dimension gauge specification page. We can scroll down and look at the required dimensions. The first required specification is whether the gauge moves with the swing arm pivot or not. The gauge usually does not move with a pivot, but in some instances it does. If the gauge moves with the pivot, check the box. The next value required is the installed rake adjustment. This will correct for the orientation of the frame relative to the angle measurements that are taken. So if your bike has head adjustment cups installed, this would be the value that you would input here. For example, 0.5 degrees as shown in the image. The next value is the angle of the top yoke to the horizontal. As shown in the picture here, we have the digital inclinometer placed on the top of the top yoke. It's important to use a flat reference here that the digital inclinometer can sit on without rocking. If the surface of the top yoke is not appropriate, you can also use the top of the fork caps. The next value required is the angle of the top edge of the gauge to horizontal. You can see there's a diagram here indicating the positive and negative angle orientation. The measurement from the gauge top edge to the pivot center is next. That's shown by the purple arrow in this image. I'm using a straight edge to extend the top surface of the gauge so I can measure down to the pivot, and I will also correct for the radius of the bolt at the pivot center. Now, if the top of the gauge is not the zero reference for the scale, then it's necessary to specify an offset. This is shown in the image of the BMW Alpha gauge, where the zero line of the gauge is shown in dashed green, and the offset goes from the top edge of the ride height gauge down to the zero line. After you've entered all those values in the ride height gauge form, you can click Apply. You'll then see all the measurements moved up into the current gauge specification. The date and time of the ride height gauge creation is recorded, as well as the name that was specified down here in this box. And then in the MotoSPEC interface, in the ride height reference row, the ride height gauge measurement is calculated. And you can see here that by hovering over the value, it indicates for me that the dimension gauge is used. Whereas next door, the Ducati V4 RS has a mapped gauge specified, and it's noted in the pop-up. Now we'll take a look at defining a mapped gauge. I'll open up the ride height references form for column 2. You can see here that it does have a gauge currently defined. It has a date as well as a name, and we can click on the current gauge specification and see all the settings that were used when that gauge was defined. Going back to the new gauge specification, we can click on F1. This image here shows a gauge installed on an MV-F3. When we defined the dimension gauge, we provided the measurements from the pivot up to the top edge and then the angle of the gauge. MotoSPEC could then calculate the distance down from the top edge to the center of the rear axle. We'll go about it more or less completely oppositely when we're doing the map gauge. We will provide all the settings that are currently in the bike to MotoSPEC so it can calculate the swing arm angle and the position of the rear axle. We'll then also provide it with the vertical measurement up to the top edge of the gauge. MotoSPEC can then reverse calculate the position of the gauge relative to the pivot and the frame. and then define the gauge that way. So as mentioned, the first thing we need to do is go into the column and make sure all of the settings in the column are as the bike currently sits. Once that's complete, we can take 2 pairs of measurements of the swing arm length and ride height gauge. We'll pull the chain off the rear sprocket, adjust the rear axles to the shortest swing arm length, measure the swing arm length and the ride height gauge, then rotate the rear axle rearwards for the longest swing arm length, measure the longest swing arm length, and then the corresponding measurement up to the ride height gauge. Once we have those, we can come back to the form. We can give it a name. We can specify whether the gauge moves with the swing arm pivot. And then here we have the 2 pairs of measurements that we need to provide. So the shortest swing arm length and its corresponding ride height gauge measurement, longest swing arm length and its corresponding ride height gauge measurement. Once we hit calculate, MotoSPEC will do all the calculations in the background to determine the geometry of the motorcycle and the position of the gauge above the rear axle. You'll see the last saved date be populated, as well as the name will be moved up from the new gauge specification up to the current gauge. And all the settings that were in the column will be moved into this current gauge specification. In the column, you'll see the ride height reference be calculated here. This number should correspond to the ride height gauge measurement for the settings that are currently in the column. Up at the top, the ride height reference drop-down menu, that is where the rear ride height reference for that column is selected. We have options for vertical pivot to axle, as if we were to draw a horizontal line across from the pivot and measure down to the axle from that line. We can select map gauge, dimension gauge, and we can also select subframe point. The subframe point is the distance from a point on the subframe down to the rear axle. It's important that those coordinates are specified with the frame in the same orientation as it is specified in the frame dimensions. And that completes a not so short look at the rear ride height references in MotoSPEC.